Hello. So thank you all for coming here. Before we begin, I would just like a quick note that maybe don't take the practicality of what I'm going to tell you too seriously. It's just of a humorous idea. So first, I want you all to think about your passwords. So visualize them in your mind, whether you generate them with a password manager or think of them yourself. But just think about how they look, your passwords. Okay, so the funny thing is that I assume they're all within ASCII. And here you see basically usually what's within a password. And you're missing out even some control characters. But yeah, I mean, it's just practical to use them. And we have 94 chars, so which is not a lot. But I mean, you can't be blamed because password generators basically don't give you a lot of options. So here you only have not even the whole ASCII char. You see this password, and from nowadays perspective, we would probably say it's quite secure. But if we take a closer look, let's maybe take a look at the mask attacks in Hashcat. So there we also have different char sets, and you're probably all familiar with them. For example, we can, if we think that the password is something like this, we can just use $U for uppercase and so on. But we also have the B option, and we could also brute force it with this. So question to you, has anyone used the B in password cracking before? Crazy, wow, okay. I thought so, but you're actually missing quite on some possible passwords when the password has, for example, control characters in it. And with the B option, you can actually brute force everything. If we take a look at how the password actually gets encoded, so we have UTF-8 input, and we see the output bytes look like this. So we have a 1-to-1 ratio, we have 14 chars and 14 bytes. Looks good, right? But let's see how the UTF-8 actually is structured. And depending on the character, we get different bytes. So different amount of bytes. So for ASCII, we only have 1 byte. But then for more complex characters, we can get more bytes. And here we can see the compounds of Unicode, for example. And the funny thing, what we can see here are, we have emojis. So let's see what happens when we encode an emoji. And we get 4 bytes. So it's a 1-to-4 ratio. So we get way more bytes that would need to get brute forced with only 1 character. And it gets more funny if we take a look at compound emojis, because this one is consists of a woman with a different skin tone, and it's glued to a heart and so on. So we basically have 28 bytes in total, which is a ratio of 1 to 28. So with 1 emoji, we have double the amount of bytes than the seemingly secure password that we saw earlier. So with this, we can actually go back to the roots and our beloved passwords, which is 1, 2, 3, 4, 5, 6. I mean, it would be easy to brute force, as also exists in word lists, and we don't get a lot of bytes, but we can have this one. It's 1, 2, 3, 4, 5, 6, and we have 36 bytes. So try to brute force this. We can also take it with password. So we don't do password, but instead do password with 32 bytes. So we can also get a bit funky and think of passwords like this. 35 bytes. or just a memo and have 38 bytes to crack. And it's probably easier to remember. All right. Thank you.